Hello everybody, my name is Lee Snyder, the product manager at Trimble Solutions USA, and I also have with me Ian Warner, who's the product manager for the Trimble Buildings Field Technology Group, and today we want to discuss layout for construction workflows. So I'm going to go through and start in Tekla Structures and show how we can create layout points, how we can export those to share them with the field team. And then Ian will show how those can be brought in and utilized in the robotic total stations out on site or also in a fabrication shop. So to begin, let's switch over to Tekla Structures and I'll begin this workflow. So the first thing that we'll do is come in and create some IFC files. So I'll just come up here to File, down to Export, and choose the IFC setting. And then we'll create a couple different options here. So the first one that we'll create will just be for a traditional TFL export. This is just if we're doing layout for concrete or anchor bolts or steel or whatever the case may be. Basically anything except for shop layout. So we'll leave the file format at IFC. I'll just change this to the Coordination View 2.0. If you want, you can include additional properties. These will be visible in Trimble Field Link. So I'm just going to choose these IFC change management settings. This includes a lot of additional information such as the piece mark, profile, grade of material, that sort of stuff, things that may be interesting there. And then I'll go ahead and change this to export all objects from the model origin, or we could do from a base point or a specific location within the model depending upon our project settings. And then over here on the Advanced tab, I can come in and I can choose to include additional information. So if I want the assembly data, which we do in this case, I'll send that. We'll also send the bolt information. If you want to see the welds, you can. Typically that's not necessary there in TFL. And then you can choose to send the grid information as well as the rebar and surface treatment. So once that's set up, I'll just go ahead and click on export. That will then go and generate this TFL export file. And then we'll go in and create our second file, which we'll use for the shop assembly layout. So let's configure these settings. I'll hit the drop down here and change this to the still fabrication view. This fabrication view will bring in the bolt holes in the material, unlike the coordination view. So those bolt holes, those will be important specifically when we're doing layout. We can leave the IFC change management. Those property sets will be fine. Over here on the Advanced tab, what we'll do is we'll come in and deselect the bolts. So that way we're just going to see the holes in the material. If you want the bolts, obviously we can include those. But for this, I'm just going to leave those excluded for now. So let's go ahead and change our name up here. And let's just call this the steel model with holes, no bolts. And that way we know specifically what we're exporting. Then I'll just go ahead and click on Export. And then these are the two files that we can send over and we can view in Trimble Field Link in context with the layout points which we're about to create. So now that the IFC files are complete, let's go ahead and take a look at how we would then insert the layout points here into the model. So the first option that we have here is just to insert layout points manually. So I can activate the layout point and I can give these a group name so they'll be organized. I can give the individual points a name, which will be the prefix to the point. I can define the size and the shape. And once I do that, then I can just start picking objects or locations here within the model that are important to me for my layout. So for example, I can come in and I can snap to these bolts within the model if we were using this for shop layout and these were critical bolt locations that we wanted to locate. Then I can just click on those and insert those layout points into the model. Now there are a lot of times where you don't want to have to go in and click every individual object each time to insert layout points. So that's where we can use the layout point applicator, which uses filters to find groups of objects like anchor rods in the model. And it'll find all of those and automatically insert a layout point for those. So we could do the same thing for steel or concrete. So for example, these pad footings, I can just insert those there into the model. Now I have layout points at all of my anchor rods, all of the corners of my pad footings. I have the manually added layout points there for my shop layout. And now what I can do is I can come up to Manage and open up our Layout Manager. Now if you have certain shop or job site layout coordinate systems that you need to match, we can easily do that using the base point. So over here is our project coordinate base point that we need to use. When we initially inserted the layout points, you can see here we're just referencing those from the model origin. But if I go back to the anchor bolt group, I have the option to choose the model origin or the base point, which is the project coordinate, which will then change all of the XYZ information for these layout points to match those project coordinates. So I can do the same thing for the shot bolts. I can do this on a group by group basis, or I can change all of them all at one time. And I can set up as many base points as needed. And then what I can do is I can come up here and hit export to export the TFL file. We can come in and give this a name. So let's just call this layout info, and we'll save it as that name. Even prior to running the export, if we want to change the location or the coordinate systems, we can do that. Let's just go ahead and leave this as what's already defined in the groups and click on export. And what that will do is it will generate our TFL file that we can then package together with the IFC files to bring into Trimble Field Link to begin our layout.
All right, now that we've gotten the files from Tekla, we can go ahead and transfer those via Trimble Connect into Trimble Field Link. Will be a folder automatically created when you download Trimble Field Link. It also has a jobs folder, and I went ahead and created a folder for this project just titled Tekla at this point. But you can see the 3 files we got from Lee over at Tekla. And now that we have that, we'll go ahead and launch Trimble Field Link. While we're launching Trimble Field Link, it's important to know that there are a few different versions out there. So we have a base, core, and advanced additional modules such as the surface module and site control. So we're going to go ahead with the advanced options here and go ahead and launch. Trimble Field Link will be the same software that you run on your controller for Trimble Robotic Total Stations, Trimble Rapid Positioning Systems, GNSS systems, as well as Trimble Field Link Office on your desktop computer. As long as you're running Windows 10, we can run Trimble Field Link on your computer as well. So now that Trimble Field Link has opened, you'll see they opened up the last project. If you open it for the first time, it'll open a brand new project with no data in there. First thing we can do, you can see we have the most used icons across the top. We have create, measure, and device. If we go under more, there is jobs. And since we're going to start a new job, we're going to manage a new job. And I don't have a project in here created, so I'm going to create a brand new project for this one. We're going to title this Tekla to Trimble Field Link Workflows. If I could spell, that would help quite a bit. We'll create that project. Now we can go in and we can actually import the Trimble Field Link file that Lee created earlier in Tekla. We can actually start the project just by clicking on TFL and say open. But this one we wanted to go ahead and give it a new project name, so I'm going to import the TFL, and that'll contain all the points. And as we click the import, you'll see that it'll give us 106 points imported with that TFL project coming out of Tekla. We're also going to take that TFL export IFC model. We're going to go ahead and import that as well. So you'll see it's processing the geometry. It'll give you a completion here in a second. And now we can immediately go to create from model to go ahead and start creating points on that model. You also see under create, we can also draw line work. We can connect points or modify some of the created line work here under the line work tool. We have point manager to key in points or edit points or manage offset points and create those points as well. We obviously can create points from a model or a PDF background or quite a few other background files. We can create standard grid points, and we can also create patterns for items such as anchor bolts, column offsets, offsets for light pole bases or other items out there as well. So if you have consistent patterns that repeat for points you have to lay out, this pattern tool is easy to create and share across all your different layout devices. So we're going to go ahead and lay out from model. You'll see that we have a green bar saying everything imported correctly. You can see the file in wireframe that we imported, and the points are overlaid. If I go up to this upper right hand corner, we have a couple preset snap views here. So we have an isometric where you can look at it in 3D. We can go from one side on the elevation view to another side on the elevation view. This 4 arrows is zoom extents. And we also have a plan view, so if you want to drop down from the top. So right now, if I move around, we're in 2D. We're actually looking at this in plan view and locked into that perspective. If I toggle this button right here, we'll go ahead and orbit in 3D. So now you can see we can spin around this model here, zoom in on those points created earlier in Tekla on the assemblies, and if we want to, we can actually go in here to these map options, turn this into a solid model, and get a little better perspective of what's going on in that project. It's a little bit easier to understand in solid model mode maybe than in the wireframe mode. We also have some levels of transparencies here so you can see through the model and see those points that were created. I'm going to go ahead and leave it in this 25% transparency mode here, and we'll go ahead and look at the model. So in this example, we may have gotten points at the top of the pier pads, but we actually want to go ahead and create points along the bottom of this of all these pads. So we could isolate this and click on one of these CAD snaps here to go to the endpoints and go individually one at a time to create those points. You can see here I was kind of overlaid in a couple different areas, so it created points simultaneously. But I'm going to go ahead and clear that. And using the advanced layer tools, we'll go ahead and turn on the layers. If I click on one of these piers, it tells me which layer that's on. That's on that pad footing layer. I can go ahead and isolate that to just the pad footings. We'll turn off the layer manager, and I'm going to look at this in side view. Now I can isolate this item, use my little window select tool. We'll highlight across the entire bottom of all those pads, and we'll go ahead and give it a name. So I like to use feature codes, so we'll see pad footing, start with 1,000 so you have room to grow. We'll call this pad footing in the descriptions, and then I could either scroll all the way down to try to find that pad footing layer, or I could create a layer just for the points, and I will call this pad footings as well. So we'll have a layer that'll isolate just those points. We got a preview here. We should have 48 points created. Press the button, and we automatically have every one of those bottom of pad footing points created very, very quickly. So we'll go ahead and we'll turn the rest of the layers back on and close the layer tool. We also have an undo button just in case you do something you don't want to complete. We can actually hit the undo button and do the last action that you just completed in that menu. All right, so now if we wanted to isolate a certain section for prefabrication or whatever you want to do here, I can go ahead and drag that into an isometric view, put it back into 2D format, and I'm going to lock it down here. And then we can also isolate a certain area for specific layout applications. So this one I'm going to call Assembly Section 1, and we will go ahead and create that. And as we drag these 6-sided arrows to a certain area, we can start to isolate maybe just that stair on the right-hand side. So we'll focus in on that area there, make sure we've got everything, spin it around in 3D. All right. Now we should be isolated. We'll make sure all the other, let's see, maybe we'll turn off the grid layer. So if I tap on that, tell me which layer is available. We'll turn off the grids just so we can focus in on this certain area here. So for this example, we may want to actually set this up to assemble in the shop floor, but laying down. So we may want to try to create some control points at the top edges of the stair stringer. And to do that, we might want to go ahead and change the visibility settings here and turn back into wireframe, just so we can try to make sure we're snapping on the direct top corner of these stairs here. All right, now that we have our area isolated, well, we go ahead and try to take the main piece of steel, and we'll use that as our control lines for the entire assembly. So if I go ahead and turn on my layer tool, we will isolate this stair stringer. Looks like that's on the plate layer. So now that we've got that isolated, we can use some of these points as the actual control points when we set up the total station. So right now we have it selected on endpoints. I'm going to pick the few endpoints here that I can find when we're laying this system down with the stair stringer up. in there, and we'll do one more along this corner here. So we'll use those as our 4 control points. Go ahead and create, and so now I have that assembly basically ready to lay out on the floor. If we turn on the rest of the layers, you can actually see there's a bunch of bolts and other items in here that we may need to lay out with the total station. If we kind of zoom in on the side of this bolt and close our layer tool, you can see I can also pick the centers of arcs and circles. So I'm going to turn off endpoints, just do arcs and circles, make sure I don't have anything selected. And if I pick on one edge of this arc and circle, you'll see it creates a point along that face. If I grab this bolt, we can create points on either side of that nut. And then if we grab this plate, I can create another point. We can also do this with the window selection tool and just grab the entire bolt pattern here. So if I do that, you're going to see it creates 9 points along each of the center points where it's hitting the face of the bolts, the face of the item it's bolting to, the face of the nut, and the other end of the bolt here. So quite a few points along that area. Again, if you want to isolate just one of those items, we can do that as well. For now, I'm going to go ahead and not create those points, and I'm going to show you how we can go ahead and double check with another model just to make sure that we're getting the points in the right location. So I'm going to go to Jobs, Manage, Import, and I'm going to grab that other file that was saved out of Tekla that has the steel model with the holes but no bolts. So if we're actually going to fab this up in the shop, we might want to just use the steel model with no bolts in there, so we can lay out the holes at the first time. So now if I go to Create from Model, you can see we're isolated, or we've got kind of a different view on the colorization here. We're going to go ahead and turn our section box back on, and we're going to zoom in, like in 2D, zoom into that same location here and see if we can find the centers of these bolt holes. Alright, so we're going to zoom in on these circles, these bolt locations, and with the holes going through the steel, and we're going to lay out the center of those bolts. So if I grab one face, if I click off on the right hand side, let's go ahead and name this. So we'll call this a bolt hole 1000, bolt hole. And we'll actually go ahead and put these points on their own layer as well. Alright, so we'll create that single point, and now we'll save that name as we go through each of these stair stringer locations and start to create points for each of those center points. Oops, clear. Sometimes it helps just do one at a time if you're trying to get very specific on your locations. Alright, so that's 4 of those for now. That should be sufficient to be able to show the point. So even with that assembly type here, we can actually just switch right back, go back to the previous version of the model. And I think that was the TFL export. We'll import that model back in. You'll see all the colorization, and now we're sure that those points are the exact center point of the hole locations for us. Alright, we'll go to Create from Model again, and turn that section back on now that we have the new model in here. You can see if we zoom into that specific area, you'll see those bolt holes are in the front face of that C-channel. Okay, so the nice thing about having the IFC model is it brings in all that BIM information with each of the objects. If I go ahead and press the I button down below here, and I click on one of these stair treads, it actually tells me what the length of the tread, I think that's probably the depth basically on the vertical elevation. Each one of these items has its own GUID, GUID, to identify that item as it goes through design and fabrication all the way to assembly and erection out in the field. It tells you the material that's available. We have quantities, we have elevations, weights, center of gravity, all sorts of information about that object that will help people as they're laying it out. They can actually call back to the folks doing the installations, and they can grab the exact correct tread or item that they're installing out in the field. So a really nice way to go through and make sure that you're getting the exact right piece installed in the right location every time. So lots of information stored behind each of those objects. So now that we've done some of the data prep, we'll actually use the emulator mode on my version of Trimble Field Link, and I'm going to go ahead and pretend like we're going to connect to a device. So
no target.
Kind of fake this thing out for a little bit. Once you have connected to the device, we have a couple different options in here. We can complete a setup. We can check some elevations. We can use it like a theodolite and set 0 angles and turn 90s and take distance shots that way. We have some quick plumb tools as well as some measurement tools in there. And obviously you can change settings on your instrument and your devices out there. But for now, I want to show you a setup. So if we wanted to set this assembly up in the shop for fabrication, we'd actually come in here, and there's a couple different modes that we're showing right now in the emulator. So we have a setup anywhere. We could set the total station up on the project, maybe out here in the dirt. We could shoot 2 of the grid intersections, and it would triangulate the position of the robotic total station, and we could lay out the rest of the project from that location on site. The other option we're showing right here is the component-based setup. So with component-based setup, using those control points, those assembly control points we put on the end of the C channel here, we can actually shoot 3 of those control points, and if this stringer is now laying down on the ground, the entire model will be repositioned in the controller so that the total station understands that this assembly is laying down, and we can point to any of these other parts or items or anything else we need to weld onto that assembly using the robotic total station, either in the prism mode, or we can switch over into the laser mode and point directly to it with the laser beam. So we're a little tough to fake that out on the emulator, but basically if we shot those 3 control points, the instrument would now consider that this position is laying down and that we're looking at the bottom of the stairs. And we shot those 3 points, and now we could start to lay out all the bolt holes and any other points we had created during that data prep operation. So a really convenient tool for doing shop layout or assembly out on site, or tilt-up panels or prefab items out in the field as well. There are a couple other layout options that aren't shown during our emulator session here. We can set up over a known point, and we can also use a panorama photo that we can take images from some of our total stations and use that panorama image to do an entire setup as well. Okay, once we have the instrument set up, we can actually then go into the measure mode. So under measure, we can do things, basic layout for points, lines, arcs, and so forth. We can collect information out in the field for as-builts or any changes or deviations out in the field we may want to collect back in and send back to the office. We also have some tools that allow for wall penetration, so we can use the laser mode to point to items that'll be installed on the wall, like stair stringers or pipes going through concrete core walls, other types of penetrations there through walls. We can check surfaces, walls, floors, or ceilings to check the flatness and get reports based upon certain tolerances if we want to set those in there as well. We can lay out planes and sloping planes and ADA planes, and obviously we can change our settings there for what will be an intolerance shot and a few other items. So for now, I'll just show on layouts. Obviously we haven't set up the instrument since I'm in an emulator mode here. But typically we can pick points, we can create lists of points using our little filter button here as well. One of the nice things about Trimble Field Link and using a 3D model or a PDF, if it's a vectorized PDF, is we can actually just click over to line work. And we can use any of the lines that are along this project to actually lay out anything in here. So if we wanted to say we're going to lay out the bottom of the stringer, I would isolate that down, zoom in to the very bottom of that C channel. I would click on that line. Oops. And let me get into a good position here. Right, we'd click on that line, and then you can see we created a bunch of points along that line. If I go into the input form, I can say I have a 0 offset. I could even say I have a 0 interval. And if I go back to that image, you can see I can stake out anywhere along that line Typically, if I'm staking along that line, using a down from the start point and out or offset left or right to show me where I am when I'm staking those individual lines. You can also stake out curves or transfer some of those points from the floor to the ceiling as well. So even if we shoot points along this line or we shoot intervals along that line, as long as we store those points, we'll have a record of where every one of those points were shot in the field, and we have some documentation to actually show that we really did install items in the correct location and with the correct tolerances. So all that information can be stored in the TFL file. That TFL file can be sent directly back up through Trimble Connect into Tekla, and you can import that entire laid out point file into Tekla and do some visual observations or update the model for any changes that were made out in the field.
All right, thanks for that great overview, Ian. As he just mentioned, any points that are captured by the robotic total station can be sent back and imported into Tekla Structures, similar to how we created the export using the Layout Manager. If you'd like additional information about this, you can search for the Layout Manager in the Tekla User Assistance. That will give you step-by-step instructions about how to import and export, and an overview of all of the functionality of the Layout Manager. That wraps up what we planned to show today. If you're interested in learning more, you can visit buildings.trimble.com. And if you come up here to the product catalog, you can see a link to all of the building products within the Trimble Buildings division. Here you can click on the link for tekla.com if you want to learn more information or where to purchase or to see a demo. Over here on the left under the Field Technology groups, you can click on Layout. That will give you more information about the robotic total station, which is what we've been discussing, or all of these other field technology capabilities that are available. If you want to purchase the robotic total station or any other field technology, you can just click on this Where to Buy, and then put in the area of the world that you are, and it will give you contact information, and you can reach out to the dealer in that way, or you can just come over here and click on the button to have a dealer contact you directly. If you have any questions, feel free to reach out to Ian or me directly, and as always, thank you for watching.